Massimo Pigliucci, it's good to see you again.
Great to see you. It has been some time.
I know you've become a very famous man, and it's hard to get to. You're single-handedly reviving Stoicism across the world. So
I'm getting some help from others, but yeah, it's been taking a lot of my time recently. That's right.
It's all joking aside, though. I mean, I do think you've started something. As professors, we get books sent to us for free, sort of to either try out in our class. I've gotten already 2 books on Stoicism this year by people other than you, and so I guess there's something brewing.
Just the other day, we had here in New York, we had what we call a Stoicon X, so a mini Stoicon conference. And there were 3 people, myself, Don Robertson, and Bill Irvine. And it turns out that all 3 of us have put out new books this year, just this year. So yeah, there is quite a bit going on in that area.
Is there a debate developing within that community, or is it still pretty much everybody's on the vanguard together, sort of saying, hey, let's do this? Or is it starting to now differentiate within?
No, just like any human community, you'll have differentiation and debates. There are so-called, what do they call themselves, traditional Stoics who think that in order to consider yourself a Stoic, you really need to buy also in the Stoic metaphysics, and therefore being a pantheist. And most of us say, no, not really. You can definitely be a Stoic without being a pantheist, and that's that kind of stuff. There's also some people that are using Stoicism for sort of making money and becoming successful entrepreneurs, which is kind of a distortion of the whole thing, because Stoicism is definitely not about making money. It's about becoming a better human being.
I guess that was to be expected, though, because they did the same thing with mindfulness meditation, right? I mean, Correct. It's become very much a corporate practice to try and increase productivity and stuff like that. Well, today we're not here to talk about Stoicism.
Nope.
And I am here with, of course, Massimo Pigliucci, the K.D. Irani Professor of Philosophy at the City College of the City University of New York, author of How to Be a Stoic, an international bestseller, translated into multiple languages. And have I left anything out?
Nah, don't worry about it.
And I'm Dan Kaufman, Professor of Philosophy at Missouri State University. This is the Sophia program. Welcome to everyone. Massimo, today we're going to talk about an issue that arises in the philosophy of science and has been a major topic of philosophical discussion. Almost all the major philosophers of the 20th century who work across these areas have written on this, and that's what's called natural kinds.
Yep.
And I want to talk about the issue in general. What the issues are with respect to natural kinds, then talk about natural kinds in science, and lastly, my ulterior motive is I want to ask you. I want to pick your brain on the question of natural kinds as it attaches to contemporary, very fierce debates going on in the area of sex and gender. Because it seems to me that this issue is relevant to at least the sex side of the sex-gender divide. And so I wanted to see what your views were on that.
So in other words, you want to get me into trouble?
Not at all.
Right.
No, not at all, actually. I want to keep it relatively narrow on just the issue of sex and how biologists and people who study animals and other things think of this. I am not asking you to weigh in on this debate.
You have no idea how little it takes these days to get into trouble.
Oh, I have plenty of ideas. Your reputation actually matters. Mine doesn't. I mean, mine is shot already, so it's sort of...
Don't worry. We'll do what we do, and then we'll see what happens.
Yes. Okay, so first of all, Massimo, as you understand it, what are natural kinds, or at least what are they supposed to be, and what is the philosophical issue with respect to them?
Well, that's a good question, because as you mentioned, there is actually a lot of disagreement about even whether natural kinds actually exist in the first place. But I suppose there's been a fairly large number of philosophies over history and even recently that has supposed that there are some things out there that there are non-arbitrary ways to, as the phrase often goes, cut nature at its joints. That is, there are certain things that are about nature that are not just our perception, they're not arbitrary categories, they're not sort of the way human beings make sense of a messy world out there, they really are natural categories. They are things that once we recognize them, there's little discussion that they ought to be, that they are there. Now, as a general idea, that's interesting. It's an idea really in metaphysics more than in philosophy of science. Although, of course, any philosophy of science has to deal with some kind of underlying metaphysics. It also actually is concerned philosophy of mathematics, not just philosophy of science, and a number of other areas of philosophy. A number of people have denied that is the case, that the notion that nature can be curved at its joints is just human projection. It's the result of our quest for order and understanding, and that it's actually really nothing out there. Nature is what it is. It's a mess of different things that act in different ways, and there is no rhyme or reason to it. So the question, of course, often hinges about, well, if you claim that there are natural kinds, give me an example, right? And I mean, I guess one of the most compelling examples, as far as at least philosophy of science is concerned, of alleged natural kinds are things like the properties of the elements, elemental properties, right? So atomic number or things like that. After all, we have a classification of elements, and it seems that classification of elements based on atomic numbers and other properties is a natural classification. It looks like it's not built by human beings arbitrarily. It looks like there is an actual progression from helium all the way, from hydrogen and helium all the way to the heavy elements. There seems to be a structure, and that structure doesn't seem to be imposed by human beings. So that is one of the classic examples of natural kinds. Even that one has been subjected to objections, however, because there are now that we know a little bit more than Mendeleev knew about chemistry and physics. Well, as it turns out, there are elements actually decay into each other. Things can be stripped of their electrons and then become something else. They become ions, so they can be stripped of their inner core and they decay into a different kind of element. So it's like even there, that seems to be a little bit of a question about, but isn't this just a sort of again a way for us to make sense of what a reality that is actually in its underlying sense more complex?
So let me ask you.
So what would you think about that, or are you thinking about other examples?
I don't have any. I don't want to say what I don't want to think anything yet, because I still want to get. I want to get the purely exegetical part out of it, and I do want to sort of go through sciences, ending with biology, because that's where I'm really interested.
Right.
So to believe in natural kinds, I guess, is to be a kind of realist, right?
Yes.
And let me ask you this, because you and I have had a number of very interesting and detailed discussions about realism and anti-realism. Are there different issues in the area of realism about natural kinds as opposed to realism in general? So the reason I'm asking is because what you just described as to whether, there's sort of a way that nature is independent of our systems of classification, or whether our systems of classification are to a certain extent prior, such that one has to adopt some sort of anti-realist or constructivist metaphysics. Are the issues between those positions pretty much replicated at the level of natural kinds? Or are there distinct issues that arise with respect to realism, anti-realism, and constructivism about natural kinds, as far as you're concerned?
I can't think of specific issues other than the obvious one, which is when we're talking about natural kinds in science, then presumably there is actually a very heavy empirical component to it, like as opposed to, let's say, the philosophy of mathematics, right? If we're talking about, the ontology of mathematical structures and things like your realism about numbers and other mathematical structures, it's hard to imagine how would you possibly check that, in any sort of empirically driven way. But if we're talking about, chemistry or biology, the other obvious example until not that long ago of natural kinds comes from biology, species, biological species. Well, we know a lot now in terms empirically about both, elements and how they change into each other, and certainly even about biological species. So we can actually take a close look at the empirical evidence and say, yeah, but does that really sound to you like, a sort of a joint of nature, or does it sound like a mess? Does it look even empirically like a mess that we're just trying, it's fine to come up with arbitrary categories to make sense of it in terms of sort of human use, but it's not really a reflection of any deep ontology out there, right? And so I think biological species are an even better example, probably, than elements. Because, so the issue with biological species, of course, before Darwin, those were supposed to be, there was assumed to be natural kinds, specifically created individually by a creator God, right? Right. So if we're talking about Linnaeus, or if we're talking about anybody before Darwin, of course, biological species are natural kinds. They are direct creations of God. Now, once Darwin came onto the scene, then the debate in biology has been pretty sort of long and really convoluted, and in some cases even harsh, about the nature of biological species. I mean, last time I checked, this was a number of years ago, there were like more than 20 different biological species concepts out there, which right there tells you that there's something about that constructivism has a good point. If biologists themselves cannot agree on what a species actually is, even if they propose like 20 different definitions of it, then it seems like it's hard to get them to agree that there is any cutting of nature at its joint. My understanding currently, as an evolutionary biologist, is that the dominant biological species concepts are phylogenetic in nature, which means that they take into account the fact that species, of course, change continuously over time. Phylogeny is just an evolutionary tree, obviously, and that there is no sharp dividing point anywhere along those lines. So what we today call Homo sapiens, our own species, if you go far back enough in time, you will get a situation where it's not clear where Homo sapiens started and whatever came before us actually ended, right? So there is a continuum. That varies between different taxa. I mean, it's different when you're looking at vertebrates versus insects versus plants versus bacteria. I mean, most people don't even know what to make of the concept of a bacterial species, for instance. They tend to talk about genetic lineages rather than species. Don't
bacteria and viruses push on the very idea of the definition of life itself?
Well, especially viruses. I mean, there's really little doubt that bacteria are alive, and in fact, the early forms of life were some kind of bacteria. But viruses is much more complicated, because viruses, of course, are entirely parasitic on already living organisms. They don't have their own metabolism. They are parasite on the metabolism of their host, and they seem to be evolutionarily derived, meaning they're not primitive kind of things. Because they need...
So in the beginning, they were not viruses.
That's right. There were no viruses, because viruses need an already existing organism in order to survive and reproduce. So viruses, do push the definition of life itself. But even there, if we're talking about the phylogeny of viruses or of bacteria, there doesn't seem to be any sharp point, any sharp distinction. It's a lot of continuous variation. And moreover, there just doesn't seem to be a single species concept that actually cuts across all of these biological groups, which again seems to indicate fairly strongly that at least in biology, or at least when it comes to biological species, these are not natural kinds.
Okay, well let's talk about that for a minute, and let's talk use simpler cases first, because it's not clear to me that there has to be sharp demarcations in order to be able to say that there are natural kinds. In other words, one of the things I want to ask you is whether, if there are natural kinds, that indicates some sort of essentialism, which is what you would need to make sharp demarcations. But let's go to a simpler example. Our planet's natural is a planet a natural kind, as opposed to, let's say, a satellite, or as opposed to, let's say, how do you understand the landscape in terms of the other sciences, the more basic sciences, where perhaps you don't have the sort of bleeding that you have in biology because these things are not undergoing a fundamental sort of change on an ongoing basis, right?
Right. Well, I'll tell you what. I'm still pissed that Pluto is not a planet anymore. So I still have to recover from that bit of.
So what is it now classified as if it's not a planet? It's not a satellite, is it?
No, it's a planetoid, whatever the hell that means. But that's a good example, right? So no, it turns out there are no sharp distinctions even there, for a number of reasons. So Pluto is the obvious example. So most planets actually orbit around the sun on essentially the same plane. All the orbits are aligned on the same plane. Pluto is completely off of that plane, which seem to indicate a different origin for the planet. Or for the planetoid, excuse me. So that's one of the criteria that people use. So it seems to be a very different kind of things. There are asteroids that are fairly large in the asteroid belt, for instance, between Mars and Jupiter, and it's not clear why they wouldn't be planets as opposed to asteroids. It's a continuum of sizes there. There are satellites that orbit around Jupiter or Saturn that are bigger than some planets, or they're about the same size as some planets. So size there also doesn't seem to be the case. More importantly, or more interestingly, I think, some of the giant gas planets like Jupiter actually produce more energy internally than they receive from the sun, which makes them a category somewhere in between stars.
A planet and a star.
Sure, yeah,
I was just going to ask you about, well, surely stars are a natural kind, but now it sounds like you're saying,
right. And also among stars themselves, of course, there are all sorts of different kinds that are known to have different evolutions. Some stars, depending on their mass and their chemical constitution, end up in a particular way, like, they explode and they eventually collapse and become a black hole. Others just explode and sort of dissipate. Others just stay there and shrink a little bit and don't do much else. So even there seems to be a lot of variation. So much so that, broadly speaking, we don't have much of a trouble telling sort of planets from satellites from stars. But there are definitely intermediate situations that make it clear that the distinctions between these classes are not sharp. Now, whether that's a problem for natural kinds, you're right. That's a different issue.
So are you, earlier discussions, you described yourself as a scientific realist. Now, within the philosophy of science, that typically means that one is a realist about theoretical entities. But let's use the term more broadly. Does your scientific realism extend to natural kinds? Are you a realist about natural kinds? And if so, why so? And if not, why not? You don't need to commit to specific ones, but just are you inclined to think that there really are natural kinds, or
not a lot? And in fact, my thinking has been changing also about realism per se, because. So there is an even broader version of realism that says, that has to do with whether there is a mind-independent universe out there.
Yes, metaphysical realism.
Metaphysical. Yeah. Now, in that sense, I definitely consider myself a realist. There's no question. I think that anybody who argues that, the universe is all in our mind and, there is some kind of solipsism or idealism, I don't go for that sort of stuff. I think that's... it's logically possible, obviously. As you know, idealism is impossible to refute as a formal argument. But it just doesn't fit with anything that we know about the universe. It just seems to require a sort of a leap of faith almost in reconstructing why things then look in a certain way. So in that sense, I'm a realist. When it comes to theoretical entities, I'm actually starting to get a little bit more cautious.
Could you say why, even though that's not our topic, because you and I have spoken about this before.
Right.
So I'd be interested to hear why your views have changed about things like quarks or muons or whatever it is that.
Well, because the more you study the history of science, the more you realize that those things, those theoretical entities we're talking about actually change, sometimes dramatically. And even when scientists use the same name for a particular theoretical construct, they actually don't refer to the same thing. The obvious example is mass, right? So mass, even though both Newton and Einstein talk about mass, what they mean with that concept is completely different. It has nothing to do with each other. And it's changing even more now with the discovery of the Higgs boson, and which is the particle that allegedly gives mass to other particles. It's like this is a very different concept, theoretically speaking, from what Einstein and certainly from what Newton were thinking about. If fundamental physicists change that dramatically their theoretical sort of concepts over a period of just a couple of hundred years or less, then I'm beginning to have doubts about the stability of such theoretical entities, right? So it turns, it could very easily turn out that quarks are actually made of something else, or are actually really a different kind of thing, superstrings, whatever. And so we're going to change our mind in 10 years or 20 years or 30 years time about what those theoretical entities actually mean.
So are you towards a sort of a von Frausen-y kind of view on this? Or do you have a different version of it that you prefer?
Yeah, so not quite. So I tend to be a little bit more cautious and a little bit more agnostic about theoretical entities. Van Fraassen, who is an anti-realist for excellence.
He's the most famous example of an anti-realist about theoretical entities, so that's why I'm using him. Yeah.
Right. So he's got problems of its own, right? I mean, the anti-realist position has problems of its own. For instance, among the most famous ones is the so-called miracle argument that if in fact science deals only with empirically adequate constructions, then how is it that we're so damn successable about discovering new stuff? And
so the efficacy problem. I mean,
right.
Yeah.
So the efficacy problem, I think, is a real problem. But by the same token, since I'm definitely not a realist in terms of mathematics, and the efficacy problem turns up there as well. Right? Because mathematical realists will say, hey, isn't it a miracle that mathematics works so well? And I don't think it is a miracle. I think there are other explanations there for why mathematics occasionally turned out to work so well in the physical world. So I don't want to say that problem in and of itself is sufficient to back up the realist position. So right now, where I find myself is kind of in an awkward situation. I see the power of some realist arguments. I see the power of some anti-realist arguments, and I tend to be agnostic and fairly cautious about committing to specific instances. If you ask me, are biological species, real? I would say, well, let's talk about what do you mean by real?
Well, so what is your inclination? So if you're talking to a bunch of students in a class, and you had to sort of say, okay, this is how I'm inclined sort of to think about, let's say, theoretical entities in physics, super subatomic particles, stuff like that. How would you describe yourself at this point? I mean, because you could just sort of be sort of a quietist, right? But that's sort of a no comment view. But I don't think that's probably not what you would say, right, to a student.
No, if I had to pick up a term, I would consider myself a quasi-realist, meaning that I do think that there is something behind what we call electrons, quarks, and so on and so forth. I do think that there is an ultimate concept of something, of whatever physical entities lie behind these things. I am not sure that where we are right now, however, is in fact it, that the current physics has actually gotten to that point. I'm not even sure that it would ever get to that point. I mean, I'm not overly optimistic necessarily about fundamental physics, especially given the mess that the field is in at the moment when it comes to, for instance, this whole discussion about so-called post-empirical science.
We've talked about that. That's
right, and how to test theories, without empirical support. So it's like, whoa.
Well, but the question is how, it's not just that we're not there yet, but my question would then be, well, how would you know when you were? In other words, and In other words, I don't see how, it seems like a very precarious position to be in, right? Because you could be saying, look, I do think I'm ultimately a realist about theoretical entities. I just don't think we've gotten the right theoretical entities yet.
Right.
But then the question would be, well, how would you know when you had the right theoretical entities, given that you could always reflect on the history and say, well, this could just all change again.
Right. No, that's a very good question, and I don't have an answer for it. I don't think that we would know necessarily. I mean, sure, if you listen to some fundamental physicists, they would say that at some point they'll get to what they refer to as rather grandiosely as ultimate theory of everything, right? By that, what they mean is a theory that accounts from first principles for all of the basic constants of nature, right? All of why the electron has the charge that it has, why the proton has the mass that it has, et cetera, et cetera. Should we ever get to something like that? Okay, at that point, I'm gonna say, yeah, I feel convinced that we got to that point, but to the end of the line. But I'm not sure that we will ever get to that point, because even if so I don't even know what that would look like. And this may just be my ignorance of fundamental physics. You know, as you know, I'm a philosopher of biology, not of physics.
Yeah, I know.
So, and I don't even play one on television. So, you know, there's no reason for me to be particularly sort of confident one way or the other. But I don't know. I can't imagine what a final theory of everything will look like, because it seems to me always possible to ask the additional question of, yeah, but why that way and not other ways, right? And if you can ask that question, then it seems to me to indicate that you have not actually gotten to the bottom of it. Yeah. That there's something else that could be done. And, you know, I really love to hear a physicist about, you know, what they have to say to that question. Possibly one of those physicists who don't have a knee-jerk reaction against philosophy and say, oh, that's just for philosophers. No, it isn't. Yeah. The moment you decide as a scientist that you are in the business of getting to a ultimate theory that explains all of reality, then now you're really into philosophical territory. So it seems to me that you do owe an answer to the philosophers. Yeah.
Is there any counterpart in biology to theoretical entities in physicists? Are there things that are purely posited in biology because they are in principle unobservable once you get sort of microscopically enough, so to speak? Because aren't we learning more and more about the subconstituents of the smallest parts? And eventually, I'm assuming you're getting to a point to where even technology does not render these things observable. Is there a similar use of theoretical positing in biology?
Not
genetics
or really. Yeah, not really. I mean, gene would be the other obvious example for a natural kind, and that one is also out because the word gene refers to a bunch of different things, and even a bunch of different levels of analysis. A Mendelian gene is something that you don't actually see. You only see the results of it. What biologists call the phenotypic outcome of it. That is the effect on. So
that would be like a subatomic particle then, because that's the way physicists detect them.
Right.
And do biologists tend to be realists about those, or
not anymore? Because so then we get into the 1950s with the discovery of the structure of DNA, and people thought, that's what Mendelian genes are made of. But then, of course, the explosion of molecular biology meant that we now use the word gene to refer to a number of different things. Genes can be pieces of DNA that code for proteins. They can be pieces of DNA, very small pieces of DNA that actually alter the way in which other pieces of DNA are transcribed into proteins. They can have structural properties inside the cell. There's all sorts and then, of course, to complicate things even better, there's so-called epigenes. These are epigenetic particles that are not genes but yet are inherited, at least in some species from one generation to another. They do have phenotypic effect. So the whole thing, anybody these days who claims that genes is something that we understood and we got a good handle of it, and it's one kind of thing. It's just diluted. No serious biologist would do that. So that one also is out of the time.
Do you think that's going to change as much as our fundamental physics has changed? What I'm wondering is, if you think about from Newton to Einstein, right?
Yeah.
Or from Newton to quantum mechanics, it is a completely transformed view, right, of the world. Is something similar, you think, going to happen in biology? We're just going to have a completely fundamentally different paradigm that's going to come along?
I doubt it. Now, of course, never bet on the future because never.
Yeah, no, I'm not asking for that kind of a prediction. But
so I don't have. I forgot it. My crystal ball in my office, so it's like I'm not going to make a prediction. But no, I don't think so. And in fact, I actually wrote a paper about the fact that unlike other disciplines, particularly physics, in biology, we have never seen anything like a Kuhnian paradigm shift since Darwin.
Oh, that's interesting. You just have a paper published on this?
Yeah, I published a few years ago, actually. I'll send. Yeah, we'll send the link. And so, if you go through the history of biology since Darwin, what you see is an expansion of Darwinian ideas. It's a modification of Darwinian ideas for sure. It's a different emphasis on different aspects of the original Darwinism, but you don't see anything that is radically, sort of qualitatively different. So you see a continuous expansion of concepts and addition of things and a change of emphasis. And that's been going on now for quite some time, since Darwin published his original paper with Wallace in 1858. Still, biology is a comparatively young discipline, compared to physics, so you never know.
Yeah.
But I would be really stunned if one of these days somebody came up and said, no, you know what? Let's throw the whole thing out because there's a completely different way of understanding biology. This
is off the subject, obviously, but now it's making me wonder, could you, in a sense, say a lot about the differences between physics and biology as sciences on the grounds that the former seems subject to Kuhnian-type paradigm shifts and the latter does not, that that's sort of a basic distinction that allows you to distinguish them as sciences in sort of a fundamental way.
Yeah. Well, I'm tempted to do that, and I would be tempted to do that in terms of making a distinction between historical and non-historical sciences, right? So physics and chemistry are obviously non-historical sciences. An electron is an electron. It doesn't matter where it's been over the last 13 billion years, it's still an electron. A living organism, on the other hand, by definition, it's like by its nature, it very much matters where it's been recently and even when its ancestors have been.
Yeah.
But then there are other historical sciences, for instance, geology, where there have been paradigm shifts, right?
Is that the case?
Well, I mean, I count the whole continental drift thing in geology as a paradigm shift. I mean, that changed completely the way in which geologists looked at their discipline. So now it begins to look like it's not a matter of historical versus non-historical sciences. It may very well be that biology is its own special thing. And then if you go to social sciences, it's a mess.
Yeah,
right. Psychology has been through 4 or 5 different major theories throughout the 20th century.
Yeah,
and they still haven't settled on anything. Particularly promising. So
that's interesting. I was just thinking of Jerry Fodor, the late Jerry Fodor. Excuse me. Famously had an even narrower conception of science than you, that has to do with things like covering laws and stuff like that. And he was inclined to say that that biology is essentially natural history. And I was wondering whether what you were saying is somewhere maybe a lighter version of his maybe too extreme version.
No, I wouldn't go that far, because natural history to me means just a sort of essentially descriptive discipline where there is no underlying structure, there is no underlying theory. I completely disagree with Fodor. In fact, I published a really negative review in Nature of Fodor's What's Wrong with Darwin? What was it? Wrong with Darwin or something like that. So because and yes, you're right, the difference there does hinge on how we think about covered laws and things like that. Yeah. But no, I think that Fodor there, with all due respect, because I did have a lot of respect for Fodor, I think that one he really did get it wrong. There is an underlying structure, theoretical structure in biology, which makes it very different from natural science. If anything, psychology and sociology count to me as natural science at the moment, natural history at the moment, because they tend to be descriptive. Yeah. And every attempt that has been made so far to move away from a purely descriptive, so I'm thinking, Freudian psychoanalysis first, or behaviorism next, or evolutionary psychology now, they have all not worked particularly well. Yeah. And so I still think now, whether that is because psychology hasn't gotten there yet, and they're still waiting for their Darwin, that's possible. It's also possible that psychology is just a different kind of beast. Yeah. Where Fodor actually turns out to be right, that there is no way to move beyond.
It's ironic that Fodor thought that folk psychological explanations could be taken as a species of causal explanation, but he thought biological explanations ultimately were non-explanatory and thus essentially a form of, it's ironic. And I do think part of it has to do with the period, right? I mean, he was educated in a period which still had a lot of Hempel's sort of overarching influence, I think, that he never was able to quite shed. And I noticed that even when I was in graduate school, he was a professor of mine. So I'm back on natural kinds. So it sounds to me like you're saying, is your attitude towards natural kinds similar to your realism about theoretical entities? And that is that you're sort of agnostic, ambivalent, not ready to be an anti-realist, but not ready to stake out a strong realist position?
It's similar to that, but I'm a little bit more skeptical of natural kinds than I am of general realism. So while I do think that it's possible that physicists will get to the bottom of things and that some of their theoretical entities at some point will be the end of the line, and so we can think of them as real in a sense. In the case of natural kinds, my attitude is more one of, okay, if you think you got good examples, let's hear it, and then we'll talk about it on a case-by-case basis. And the more I hear about examples that have been thrown around, the more skeptical I become about the whole thing about natural kinds.
Okay.
But the interesting issue becomes the one that you brought up a few minutes ago, which is, well, do we need to have sharp categories, sharp distinctions, right, in order to have natural kinds or not? I guess I want to hear what you think about it, but my initial inclination is, yes, you do, because if you don't, then all of a sudden we're sliding into what exactly? If we're saying that, well, biological species are natural kinds, even though there is no solution of continuity between species, that just grade into one into each other, into the other, then in what sense are they natural kinds?
I guess, so what I was going to ask you was, is your view that there are not, or is your skepticism about natural kinds essentially reducible to a skepticism about there being essential properties, right? Because your point about demarcation would seem to suggest that you need there to be sort of essential properties in order for there to be natural kinds. But, it's worth stepping back for a second. There doesn't need to be essential properties for there to be kinds, right?
Yes.
Right. So why should there have to, in other words, things can constitute a kind even if the boundary lines between that kind and another kind is porous, right? Even on a Wittgensteinian family resemblances view, you could argue that there are kinds. It's just that the boundaries between them are fuzzy, and the way you identify a kind does involve in part an act of judgment, right? Whether X is suitably similar to the things that are the paradigmatic cases.
Correct.
So if it's possible to have kinds without essential properties, why wouldn't it be possible to have natural kinds without essential properties?
Right. So let's go back to Wittgenstein in a minute. But before we go there, I want to go back to the essentialist stuff. Mm-hmm. So I have some colleagues of mine, I should not name names, who I think are making some very bizarre moves and arguing.
In philosophy, no.
I know, right? that has never happened before. So for instance, I have a particular person in mind that has been arguing now in print for a number of years that essences don't need to be essential. They don't need to be sharp. They can be, sort of a continuum kind of thing. I want to say, well, why do you call them essences at that point? It's like, sure, you can recover the notion of essence by essentially giving up the notion of essence. It's like, fine. But why are you making that move? And so I'm kind of suspicious of the move essentially that you're just suggesting, and on singular ground. That is, can we have kinds without sharp borders? Maybe, but then what would you call them kinds? So now it's time, let me go back to Wittgenstein. So the Wittgensteinian approach is perfect in that sense. Are there such thing as games? Sure. even though Wittgenstein argued, rightly, that there is no sharp distinction anywhere. There's no single thread that connects every activity that we call game. But that's a perfect example of an anti-essentialist and I think anti-kind kind sort of approach, because well, no kidding. We invented all of those categories. So yes, we can arbitrarily refer to golf as a sport, but then somebody else, like Mark Twain, may come up and say, no, that's actually a good walk spoiled. It's not a sport because you can play while drinking beer or something like that. And then we have any agreement that we're going to have on what counts as a sport or as a game or anything else is going to come down to a matter of language use, just like Wittgenstein said, right? It's not like we can actually, on the basis of empirical observation, say, oh yeah, there it is. Anybody without a preconceived notion of what games are will arrive at that same classification. Right. I don't think that's the case.
Right.
So now the question is, are there, are all the cases of natural kinds of that type or not? I am skeptical but agnostic. I'm willing to be, I'm happy to be convinced otherwise. And that's why whenever these conversations come up, I say, well, okay, so let's talk about specifics. What's a good example of a kind that is not based on essential properties?
Yeah, I mean, I guess you could just say I refuse to use the word kinds, right? Mm-hmm. But it's very natural to say that, a porch is a different kind of thing than a basement, right?
Sure.
And so I guess I'm reluctant to sort of maybe I'm reluctant to be that philosophically rigorous, right? I mean, I don't know how else to how else do I describe the difference between porches and basements? Yeah. If I don't in some way say, well, they're different kinds of things, right? I mean, porches are things that you...
Sure, yeah. Sure. But if you use the word kind in a sort of, non-metaphysically heavy meaning, sense, then sure, colloquially, the two of us can refer to chairs as one kind of furniture and tables as a different kind of furniture. Absolutely. But
do you think that we need more than that? I mean, I guess I've always thought that because of Wittgenstein, I've always thought that the idea that somehow the only way we can sort of divide things up in the world, and now let's forget about realism for a minute. I mean, just for a second. I mean, in terms of mind independence, yeah. I've always thought just because of Wittgenstein, precisely that the notion that we need essences in order to be able to divide the things in the world up into discrete categories is just a mistake, right?
Yeah, I would agree. But if that's the case, then in what sense are we talking about natural kinds?
No, we're not talking about natural kinds. I was just sort of wanting to sort of say, okay, are there kinds at all? Do kinds at all require, in order for there to be kinds at all, does there have to be essences? And so if the answer is no, then the question becomes, well, why do there have to be essences in order to be natural kinds? Why can't natural kinds be like other kinds of kinds? That is, yes, there's an element of conventionality to them in the sense that there are going to be borderline cases that require active judgment on the grounds of sufficient similarity, right? But that's not to say that there aren't kinds, right?
Right, but I guess the move that I'm gonna resist is the one you just made, which is an equivalency or a similarity between kinds, as in different kinds of games or furniture, and natural kinds.
Yeah.
I guess I'm going to resist that one. I'm going to say that if we want to meaningfully talk about natural kinds, it's got to be something to do with essences or something to do with sharp categories, because if not,
I see.
Then I don't really know where I'm going to draw a distinction, and my way of drawing a distinction is going to be different from yours. Now, here's a radical approach that would militate against the existence of natural kinds. So, yes, the two of us as human beings, as human observers, can somewhat easily agree that the sun is a star and Earth is a planet. We can also agree that, Pluto is more similar to a planet, let's say, than a star and so on and so forth. Right. But if fundamental physicists are right, the entire universe is simply, and I use the word simply in sort of scare quotes here, is simply the manifestation of, let's say, a universal, quantum wave. Right? So it's one thing. And if it is one thing, then the fact that we perceive it at different times and in different places as discrete objects, that's in a sense a function of our position as human observers. It doesn't reflect anything fundamental about nature. The only thing that is fundamental about nature is the wave function. Of course, assuming that one particular version of quantum mechanics is the right one, but just for the sake of argument, right? Even if that's not the one, that there are others that essentially brings you to similar things. I mean, you can say, let's say the string theory is correct, for instance. Not that I'm a partisan of string theory, but let's say it is, again, for the sake of argument. Well, then it turns out that everything that we see so different and so varied in the world is actually just one fundamental kind of thing. Yeah. Strings, right? Vibrating at different frequencies, and that's all it gives, and that's what really all there is. The rest is a matter of contingent interaction between certain entities like us, characterized by certain senses and certain ways of thinking and all that sort of stuff. If that's true, it seems to me that's an argument from fundamental physics against the existence of natural kinds.
But that does presume a very strong ontological reductionism, which I would be inclined to resist, right?
Yeah.
And part of the whole idea of the anti-reductionist view is to argue that, that the kinds that the various sciences talk about are somewhat, to a certain extent, ontologically independent of one another. For example, the idea that psychological kinds are intrinsically physically heterogeneous, right?
Right, but I was going to say, so even if you reject a strong ontological reductionism, your rejection really has, it seems to me, power. It has an interesting aspect only when it comes to mental stuff. Only when it comes to sort of the ontological status of concepts, for instance, or ideas, or things like that. We talked about this in the past, and as, I do agree that those are interestingly problematic. But you wouldn't say that it's not true that planets are made of ultimately
no, certainly not,
or something like that.
I thought that you had in previous dialogue said that there are actually significant problems in a strong ontological reduction of biological types. And even you said, even in chemistry, there people have been pointing out that there's difficulties with a strong ontological reductionism.
Well, so what I think there is an issue of we don't know how to go from to have we have no idea. Even the strong fundamental, reductionists. They only do a lot of hand waving when you ask them, okay, so how do you reduce, biological species to quarks? They do a lot of this. It's in principle. Well, what's the principle here? It's like, I don't know. But it is certainly the case that everything that is physical is made of ultimately the same kind of stuff. The real interesting question, I think, is how is it that if everything is made of the same kind of stuff, you do see qualitatively different properties of some of this stuff when it gets to certain levels of complexity, right? So it's a problem of emergent properties.
Which we've discussed, yeah.
Right. And then when I'm still on board...
Nobody knows how to cash that out.
No, nobody knows that. And anybody who just dismisses it as that's just a philosophy of talk, it just either doesn't understand or it's in bad faith. That is a real problem. We don't know how emergent properties, and I'm not even making the assumption that emergent properties are strong instances of strong emergence.
Even weak emergence.
There very well be weak emergence, whatever. The question is, can you please give me a detailed explanation of how you get from strings, quarks, or whatever it is, the fundamental stuff of matter, to the two of us talking about abstract concepts? Nobody has any clue of how to do that. So in that sense, I'm not a strong reductionist. But I certainly agree that the two of us and the computer that I'm looking at and so on and so forth, we are all, in fact, made of the same fundamental stuff. Okay. So there is a distinction between stuff and properties. I think I guess that's where I'm getting. Right?
Yeah. All right. So let me ask you pose two questions about anti-realism, about natural kinds, and then I will and then let's talk about the last thing, which has to do with specifically in biology and the concept of biological sex. Okay. So there's two things that I thought would be a real problem if you are an anti-realist about natural kinds.
Okay.
The first has to do with scientific laws.
Yeah.
So if you know the reductionism literature, what you know, the traditional idea of reduction that goes back to Ernest Nagel's structure of science is the idea that when we do a reduction, we reduce the laws of one science to the laws of another, and doing so involves creating bridge laws between the natural kinds of one science and the natural kinds of another.
Right.
The idea being that what scientific laws consist of are relations between natural kinds. Now, I guess without there being natural kinds, can we even make the sense of the idea of a scientific law? Or are you happy to be done with scientific laws? I mean, that's another way to sort of go.
I'm happy to be done with scientific laws.
Okay, but can you say something about that a little bit?
Sure. No, so as you know, there are some philosophers who actually got there. Nancy Cartwright, for instance, in Why the Laws of Physics Are Wrong, or Lies. Actually, I think it's
Lies. Did you say lies?
Yeah, lies. Yeah, lies. That's a great book. I mean, it's very controversial even within philosophy, but it's a great book. Or Ian Hacking has come up with similar positions already back in the, I think, 80s or early 90s. But in fact, I discovered recently, not that recently, time flies, my friend. A couple of years ago, there was somebody who gave a seminar here at a colloquium here at the Graduate Center. And it was talking about the historical origin of the concept of laws of nature, right? And I had no idea up until that point that there was a big discussion going on for it initially among physicists. While Newton was perfectly happy to use the term laws of nature because he really did think that the laws were given by a lawgiver.
Right.
It was God that was putting this stuff out there. Galileo, before Newton, was very uncomfortable with this whole thing, and he tried not to talk about laws of nature. He talked about empirical generalizations, which is, interestingly, the way in which Nancy Cartwright talks about natural laws. So natural laws, just as empirical generalizations. What a natural law is, we tend to see that things, under similar conditions, things happen in a similar way, and we call that a law. And it's exceptionless as far as we know. But that doesn't mean that they are actual laws, meaning that doesn't mean that there are no exceptions. It doesn't mean that they were always in place. Some modern physicists also go there. Lee Smolin, for instance, has suggested that even some areas of general relativity, for instance, they may break down at very large cosmological scales. Whether he's right or not, it's not the point. The point is, here we have a theoretical physicist who is actually skeptical of the notion of natural laws. More interestingly, Smolin co-published a book a few years ago on the nature of time with a philosopher, and one of the arguments they were putting forth is that, look, what's really fundamental are not laws, but causal interactions among whatever it is that makes up the world, and that what we call laws are these regularities that come out, that emerge out of the causal interactions, which we don't actually understand. And his point was, the nature of those causal, there's nothing that prohibits those causal interactions from changing qualitatively over time. We have no idea if whatever it is that was before the Big Bang worked by the same laws, that is, by the same empirical generalization as whatever happened after the Big Bang. Now, all of this is highly speculative, but the point is that there is a way to cash out the concept of law of nature without laws. You can just think of them without talking about laws. You can just think of them as highly reliable empirical generalizations.
Of sufficient generality. I mean, the way that Fodor, part of the reason that Fodor was very conservative about what he was willing to extend the term science to was because he thought that the laws of whatever the science were had to be sufficiently general to count, in a sense. But I guess what I'm asking in this, regardless of whether you call them a law, okay, do not the relata in those generalizations have to be natural kinds? Because otherwise, couldn't you, in a sense, come up with infinitely many generalizations between relata, right?
Yeah.
But you wouldn't want to call them all laws, right? I mean, the point is that the laws have a kind of, I don't want to say they have a kind of a normativity to them, but they do have a
Yeah.
kind of force, right? That seems to presume that they don't just describe relata between conventionally described groupings of things,
Sure.
right?
But the question is, how many laws of nature are there exactly? And
I don't know. I just remember I had to remember a lot of them in high school physics, and I can't remember them all. But I mean, I'm assuming there's even more than that, right?
Right, but think about it this way. So on the one hand, in physics, actually, the trend has been toward collapsing some of these generalizations, right? So one of the trends in 20th century physics has been that, it turns out that we thought electricity and magnetism were completely different things, and each one with its own laws. But in fact, there are two aspects of a single underlying thing called electromagnetism, which has its laws that explain the emergence of the other two. Oh, emergence. I use the word emergence again. So there seems to be this trend in fundamental physics to basically reduce everything to one law. They haven't gotten there yet. In fact, they're pretty far. But that seems to be the trend, right? I mean, that what physicists want, physicists like Steven Weinberg, let's say, want is one equation that describes everything, right? That would be one law, right? One kind of generalization that describes everything. Are they going to get there or not? I don't know. But that's the trend. Go the other way, get to biology, for instance. In biology, it's a constant discussion, especially in ecology and evolutionary biology.
About whether there are laws at all.
Yeah, are there laws in biology? Well, lots of people have suggested that there are laws in biology that have to do, for instance, with metabolic relations. Like there is a very clear relationship between the surface and the volume of an organism, right? That really has to do with the way the metabolism works, but ultimately it comes down to a geometrical relationship. If you double the surface, then of course you're going to increase the volume by the cube, not by the square. So that has all sorts of very predictable, very clear implications for the metabolism of living organisms, for scaling up metabolism from bacteria all the way to sequoias and so on and so forth. Now, some people will be arguing that those are biological laws, the scaling laws are biological laws. Others say, no, that's actually just a straightforward result of chemistry. Others say, no, it's a straightforward result of geometry. Okay, it's still under debate. And to me, part of that debate has to do with these two fundamental issues. One, can we reduce an alleged law to a more underlying one? So the scaling laws in biology, are they actually the result of, essentially manifestations of chemistry? Or are they the result of manifestation even of geometry? Yes, no, maybe. And on the other hand, it has to do with how generalizable these laws are. Right? So in biology, the only law seems to be that there's always exceptions. No matter what kind of generalizations you come up with, somebody's going to eventually come up with an exception. So does it count as a law if it describes a general behavior of biological organisms with high reliability, and yet there are exceptions? A physicist would say no, but a biologist would say, well, why not? It's pretty good. It works pretty well in most cases, right? So, so for instance, one of the classic example of that kind of law comes from island biogeography, where there are very reliable regularities that tell you things like, the number of that you can predict the number of species on an island based on just two parameters: the distance of the island from mainland and the size of the island.
And that really?
Yeah, and that works pretty damn well. There are exceptions.
That's quite incredible.
There are exceptions, but it works pretty damn well. Why does it work well? Well, because the closer you are to mainland, the more likely it is that a species is going to be able to colonize from the island, from mainland. And the larger the island is, the more number of niches it may be able to host, the more diverse the environment is, and therefore the more number of species. So that law is pretty damn reliable, but there are exceptions. And so it's like, now what do I do with that? Right?
Yeah. I assume that if there are laws, they're going to have exceptions. I mean, because even the laws of physics, it seems to me, have exceptions. But it sounds to me, though, like you're saying that there's a sort of an in-between space you'd like to occupy. So you want to reject the idea that, let's just call them laws, but what we're talking about are sort of, highly reliable generalizations of a suitable generality. Okay, let's just call them that, right?
Yeah.
you want to say that, you don't want to hold the strong view that the relata in these generalizations have to be natural kinds.
Right.
But on the other hand, you also don't seem to want to be saying that, well, the relata can be any conventional grouping of things that you can find correlations between, right? So do you have any way of characterizing the in-between ground you want to stake?
Well, I'm not sure that I want to give it a name, if that's what I mean by characterize, but
they're not entirely conventional and they're not natural, so then how should we...
Well, remember that I'm a realist about the ultimate nature of the universe, right? I think that there is a universe out there that's made of actual stuff, right? So if that's the case, then it stands to reason that the universe works in a certain way. There are certain, causal relations among whatever it is that make up this universe that result in the phenomena that we observe. So I don't want to say that it's all a matter of convention, because otherwise I would have to say that we have no access whatsoever to the ultimate reality, or that there is no ultimate reality, perhaps. And I definitely don't want to go there.
I don't want to fight you forever on this, but I mean, it does seem to me though that you're painting yourself into a pretty tough spot, because look, that sounds to me like what you're saying is, well, there is an actual way the world is, which means that it does actually consist of natural kinds. It's just that we don't know what they are yet, and we might never be able to find out, is what it sounds like you're saying, right?
Well, if that natural kind turns out to be just the wave function, okay, we want to call that a natural kind?
You're saying there's a way it is, but it could be such a way that doesn't break into the kinds the way we normally think of them.
Exactly. Right.
It's going to be shit about energy and
yeah. Right.
I see. Okay.
Also, now, if we really want to go far out into who knows where land, I am still kind of intrigued. I don't buy it, but I'm intrigued by this book that came out a number of years ago by James Lediman and Don Ross called "Everything Must Go." Everything, not everything. So this is essentially a book that in what they call scientific metaphysics. Their project is to reconstruct metaphysics as a discipline that is not in the business of doing first philosophy, like Aristotle, right? Not of discovering stuff about the world, but it's in the business of making sense of what the sciences are doing. So how no individual science gives you the full picture. In Lediman and Ross's idea, the function of metaphysics is in fact to put these things together and say, okay, what kind of picture of reality comes out of the different sciences once we put them together? And one of the things that they discuss at length is this notion that it looks like fundamental physics is going in a direction where things, meaning particles, are eventually going to be gone, particularly with the discovery of the Higgs boson, which of course is a particle, but it's a particle that emerges out of a field. And so it looks like where physics is going is the ultimate nature of reality, as far as we can guess it, is fields where there are relations between points in these fields, but the points themselves are not things. And so in a sense, you have relations without relata. Sort of, right? Now, wow, it's like, if that's the case, it is a if. It's a big if. But if that's the case, and that does seem to be consistent with directions in fundamental physics at the moment, we need to rethink about what we mean by fundamental ontology here, and we need to also rethink what we mean by natural kinds. If it turns out that the ultimate nature of reality is relations between points in fields, I'm not sure what sense we can make of anything like a natural kind. Of course, the physicists do owe us an explanation of how the hell you get from relations between points on a field to, the two of us talking to each other about relations on points in a field. And they have no clue.
Yeah.
They absolutely have no clue on how to do that. But it kind of makes you think.
Yeah. Now, the other thing I was going to say in terms of a problem for being an anti-realist about natural kinds and is maybe your response is going to be what you just said. But what I was going to say was, it seems to me then that you're going to have a very difficult time avoiding, your realism turning into a kind of a Kantian nominalism, right? In other words, well, there aren't any natural kinds, or if there are, we can't discover what, we're not going to know what they are. And even if we could know what they are, we'll never know that we know. But there is a reality, and it exists independently of us. That starts to sound to me like a kind of a generic reality that then we have all the problems that you and I have discussed on other occasions that sort of Davidson raises and Quine raises and other raise about this problem with the notion of an undifferentiated generic reality that then our theories are supposed to sort of imprint themselves on or whatever.
Right.
Well, it sounds to me like you think that fundamental physics is going to provide us with this. It's not going to be a generic reality. It's going to be something like energy.
Correct. Right? Exactly. It's not going to be a generic reality. And whether it's fundamental physics going to provide us with a lot, the sort of whatever the ultimate answer is going to be, then I don't know. But what I do think is that we're getting closer and closer to that. We're getting better and better descriptions of ultimate reality. And so that ultimate reality is going to be in a certain ballpark, isn't going to be in certain other directions. So the difference with Kant is that he would argue that you cannot say anything at all about the numerator. Right? What I'm thinking, on the other hand, is more along the lines of Richard Gere perspectivism, that what science is giving you is different perspectives that point ideally toward one, ultimate realities out there. We may never actually get to somehow perceive or see or understand the ultimate reality as it actually is, but we get better and better ideas about how some of its characteristics through the phenomena to which we do have access. I mean, I don't see any reason for being particularly optimistic, about, human beings are going to be able to figure out the ultimate foundation of reality. I think it's astounding that we got as far as we did already, considering our, very limited brains that evolved to solve very limited kind of problems of a particular species of, social species of primates. It seems to me that we've already gotten to incredible points. I see no reason, however, to just think that this is going to go on forever, that eventually we're going to get to some kind of ultimate understanding of reality. We may I think we may already be running into insuperable empirical obstacles.
Yeah.
If it is true, I don't believe in post-empirical science. I think that's an oxymoron. If you have to start bringing extra empirical sort of criteria to decide between scientific theories, I don't think you're doing science anymore. I think at best you can, and I don't mean this as an insult, you can characterize that as empirically informed metaphysics. Right? So as far as I'm concerned, they're all different, with due respect to my friend Sean Carroll, the cosmologist, who just came out with a book claiming that his favorite interpretation of quantum mechanics is the real one, and whatever. I don't think so.
Of course it is, right?
Right, of course it is.
You just got to quote Feynman to him is what you need to do.
Yes. Now, the fact that I don't think so is like, who the hell are you? You don't understand quantum mechanics. But there's a lot of other physicists who do understand quantum mechanics who are not convinced at all. So the point is, I don't think we're necessarily going to get there because we're already running into issues that seem to be insuperable. Again, never say never. So that's obvious, always a caveat to have in mind. But if some of the critics of different interpretations of quantum mechanics are right, if some of the critics of string theory are right, when they say, look, if there is in some cases there is no experiment that anybody's been able to conceive that would tell us the difference between different interpretations of quantum mechanics. And in other cases, yes, there are conceivable experiments that you could do to test certain predictions of string theory, but they require more energy than multiple suns put together, and we were never going to get a kind of a particle accelerator that gets to that energy. Then, for all effective purposes, we reach the end. That's it. You're not going to go further, right?
Yeah.
I'm happy to be shown wrong by the next generation of physicists, but it's very possible that we got as close to the noumena as we ever are going to get, and that's about it. And then we're going to say, okay, so we know a lot. We know a lot about particles. We know a lot about fields. We know a lot about empirical generalizations that we call laws, and that's about it.
Yeah.
All right, I'm happy with that.
Well, then let's do the last thing. And I actually, this is nice the way this went. I didn't predict it. I thought you were going to be more realist about natural kinds. But B, I think it's a nice way. There's now a nice way to reformulate what I was going to ask you in the area of biology and specifically with regard to sexes.
Right.
Okay, so you're skeptical about natural kinds, maybe a kind of anti-realist about natural kinds. We're not going to saddle you with anything. And so you're not going to want to distinguish sex between sex and gender on the ground that sexes are natural kinds and genders are not. So let me now rephrase the question in a different way, and that is, how are we going to make the distinction between things that are demonstrably obviously conventional and things that would appear not to be, right? So in other words, look, gender is obviously demonstrably conventional. It has a lot to do with sociocultural consensuses of various sorts, and it has to do with the sort of the various social psychological expressive expectations that we assign to the different sexes, right? So gender is everything to do with sort of how we expect women and men to behave, how we expect them to dress, how we expect their personalities to function, all of that. Sexes wouldn't seem to be like that, right? Yeah. Whether or not you're male or female seems to have a substantial biological, substantial. So if you don't want to make the distinction that, well, these are natural kinds and these are merely conventional ones, how do you want to paint that distinction?
I mean, that goes down to what in biology is referred to as the gene-environment interaction problem or the nature-nurture issue, right? Whenever we come up, especially when we come up against, human behaviors, which are obviously, every human behavior is influenced by culture, no matter, even including sexual behavior, like sexual preferences.
Yes, of course. Yeah.
So in all those cases, the answer is always going to be, well, you're going to find a biological component, and notice that I'm using the word biological here, not just genetic. It's broader, right? So biological means genetic, sure, but it also means epigenetic, since now we know that there are lots of heritable epigenetic effects that are due to chemicals that are inherited from one generation to another that are not genes. There are, things like methylated groups, chemical groups on top of genes that can be histone proteins that have a certain three-dimensional conformation, so on and so forth. So there's genes, there's epigenes, and then there's actually biological effects that have to do with intrauterine effects, responses to hormones, to the external environment, to stresses. We know that human development is sensitive to a number of things that can happen very early on during that development. So when I say biological, I don't mean just genetic, although biological includes a part of genetic, right? Now, there are certain cases where we can obviously say, no matter what you think about culture, this is all biological. Eye color. Unless you wear, lenses that change the color of your eyes, I'm sorry, that's entirely genetic. There's no, and we understand the genetics pretty well. We know how many genes are involved in this thing. We know the biochemical pathways. That's pretty clear. There's no societal impact. There's no behavioral impact on eye color. But that's the simple case. Then you start getting into more complex stuff like sex. Well, sex, there certainly is, no matter what some non-biologically well-informed people would say, there certainly is a strong biological component. But there's also much more variety than one might think. I think of sex as something that has two peaks, male and female, right? And we understand the biological basis of that. The XY chromosome stuff, it's pretty well understood. But there are also exceptions. There are things in between. Some of those exceptions are the result of genetic changes. There are people with, 2 X chromosomes and 1 Y, for instance, or 3 and 1, so on and so forth. Those are going to look different, and they're going to look some kind of intermediate between the two standard sexes. There are also probably biological influences, meaning, as I said, early developmental influences that can have an effect. But largely, sex is a result of biology and particularly genetics, or chromosomal arrangement. When you start getting even further away from the straight biological into things like sexual preferences, for instance, before we even get to gender, then now the thing is much more interesting. It was recent a paper that found a significant signal for a genetic basis for gender, for sexual preference, but no gay gene, right? So there is no such a thing as a gay gene, meaning there's not a major or a small number of major genes that actually determine sexual preference. But as it turns out, there is a large number of small genes that all influence sexual preference, right? So are we going to say that sexual preference is genetically determined? Well, we're going to say that there is a significant, detectable, empirically detectable genetic influence.
Yeah.
Where the rest comes from of the variation in the population, we really don't know, right? Now, as far as gender is concerned, gender roles are definitely socially constructed, at least in very large part, right? But then there are, transgender people who claim directly things like, very vocally, things like, I always felt trapped in the wrong body. Right? Well, that sounds to me like there is something more than just convention going on, or just societal influences, because certainly no society is pushing these people to make that kind of statement. So if actually that's what they're thinking, that's what they're feeling, does that imply that there is in fact a biological component even to gender? Maybe, I don't know. It's an empirical question.
Yeah.
But ultimately, the question is, why does all of this matter, right? So the case is much simpler when it comes to sexual preferences, right? Whether being gay or not, or heterosexual, or being fluid or anything, is a result of genetics, biology, environment, culture, or a combination thereof. Why exactly does that matter? So long as the people in question do what they want to do without actually inflicting harm on other people, who cares? They should have the right to do whatever the hell they want to do.
Yeah.
So to me, all these discussions about how much biology or genetics plays into these kinds of behaviors, it's kind of a red herring. So what if it turns out, for instance, that being gay is entirely genetically determined? So now people that think that there's something wrong with being gay are going to drop their objections and they're going to say, oh, well, sorry, we were wrong. I don't think that's going to happen. At the opposite extreme. So what if it turns out that it really is entirely completely a choice of individuals with nothing about the genetics or nothing about the biology? Now what? Am I going to say, oh, no, you really should, there's something objectionable about that choice? Like, no, I'm not. It's your choice. And so as long as you don't, it doesn't matter causally where it comes from, so long as you're doing it in a way that does not actually, harm other people, fine.
Yeah. I mean, look, I'm on the record saying over and over again that I think that the solution to all of these problems, to the extent to which there are social problems, is a sort of traditional liberalism that's sort of bound by the harm principle, right? But the reason that these things come up is that increasingly the very categories are beginning to be challenged. So the same people who are inclined to say that sex is not a biological or natural characteristic, but rather a constructed one, are also now going on to say that homosexuality is not homosexuality, but rather homogenderality, right? So that now you have people with full male anatomy claiming to be lesbians, right? And understandably, a lot of the lesbians are pretty upset, partly because they fought very hard to get laws put in place to protect people on the basis of their sexual orientation, right? You have people who are full-bodied males now claiming to be women and wanting to be able to go into women's restrooms and women's changing rooms. And so, in other words, the reason why this is now becoming fraught is not because people are necessarily saying, oh, no, you shouldn't have any civil liberties. It's more that because some people are trying to literally say that there's no such thing as biological sex, or that biological sex collapses into gender. And at least one way of trying to make that distinction is to say that, well, sex is a natural category and gender is a conventional one. Right. But since we don't have access to that distinction because you're don't want to go down the road of saying that sexes are natural kinds, I guess what I was trying to get is, how should we then instead generally think about the difference between characteristics like having a male reproductive complement on the one hand, and on the other hand, characteristics like, liking pink clothes and wanting to play with tea sets as opposed to trucks and so on and so forth.
Right. So again, I don't have a general answer to that question, because that one is not the question you're asking now is one of how should we relate in a society with people that makes these kinds of claims. It's not a question about what is the status of these claims from an ontological perspective. As I said, I don't believe that there are biological categories in the sense that we were discussing earlier, but I certainly do believe that sex is largely determined by genetics, and anybody who tells you otherwise just doesn't understand or refuses to understand genetics.
You don't think we need to distinguish on the basis of nature versus convention? That's what I was getting at.
From a scientific perspective, we certainly do need to distinguish, but with the big caveat that it is a continuum, and it's not, those distinctions aren't going to be sharp. Now, from a legal, and societal perspective, that's a very interesting question. It could very well be that society is better served by just doing away with the category of gender or even sex. Why is it that when I fill out certain forms, I have to say whether I'm male or female? Who cares? Why is that relevant?
Isn't part of it the reason for things like the census and stuff like that and crime statistics? Isn't there sort of a practical purpose of it? Certainly with regard to medical research and the devotion of resources, yes, we do want to sort of identify things that male-bodied people are prone to versus things that female-bodied people are. And if we just mix them all together, that's going to make a mess out of our medical data, right?
Correct. But you shouldn't require people to do so, right? So yeah, as a male, and I'm convinced that I'm in fact a male, when I go to the doctor, I definitely answered that question.
Yeah, I have problems that my wife's not going to have, right? And vice versa. Exactly.
Even statistically speaking, there are some problems that you're going to have and she's never going to have, and vice versa. But also there are other problems, like a heart attack, for instance, that it is more likely for certain biological categories, where I use the word category in that colloquial sense.
In a non-natural kind sort of way, yes.
Or take race, right? So I'm actually an anti-realist about human races.
Right.
I think there is pretty good evidence to suggest that there is no such thing as a human race in the sense of human races, in the sense that biologists understand race as a, deep phylogenetically divided, almost different, subspecies kind of thing. There's no such thing. But that doesn't mean that, let's say, people of African-American descent are not more likely or less likely to suffer from certain diseases, and therefore they better tell their doctor.
Right. Or Ashkenazi Jews.
Or Ashkenazi Jews, or etc. Right? Yeah, so they better, it's in their own interest to tell their doctor that, hey, this is my ancestry, this is my lineage, because it does have certain statistical correlations with certain health conditions. So all I'm saying is that we should not require that kind of self-identification, precisely because it seems to be problematic for a sufficiently large number of people. But if people do want to self-identify, if people say, hey, when I go to the doctor, this is actually in my interest to tell the doctor, whether I am X, Z, or Y, yeah, of course we should do it.
But it's also in society's interest, is it not? To sort of have reliable data about the different things that tend to affect males and females, biologically speaking. It's in society's interest, right? It's not just the individual's interest, right? I want to know if females are prone to certain,
but you will have that anyway, right? Because so when medical researchers do research on, say heart attacks, they will ask their subjects the pertinent information, and if you're not willing to give that information, you're not going to be part of the trial.
Yeah.
Right. So we will have that sort of information. I'm a little more skeptical, I guess, that society needs to know that sort of stuff on things like the census. Maybe, maybe not. We're moving away from race, for instance, even in the census. So why not move away from other categories? So long as there are human beings that are living in a particular area, you can assume that those human beings are going to be a certain statistical mix of what we call males, females, and others, and therefore you can act on that basis. It's not like you're going to find a neighborhood where all of a sudden there's 99% males. and 1% females. Like, that would be really weird.
I could see it being important in crime statistics. So, I mean, let me give you an example. So there's been a recent few cases of this, which have gotten a lot of notification, where in Canada, where there are sort of peculiar laws regarding this, crimes committed by male-bodied people who identify as women are being reported as crimes committed by women, right? Now that, I think, strikes me as rather dangerous, right? I mean, and misleading. It's important to know, for example, that males, it seems to me, are wildly overrepresented in violent crimes. And if you start reporting male-bodied, self-identified women as women for the purpose of crime statistics, that's going to mess up your crime statistics, is it not?
Sure, but in that case, I mean, I don't know the details, so I'm just talking off the top.
Yeah.
But in that case, it seems to me that there's a difference between the self-reporting of the individual and the classification that the law enforcement agency is going to make for the purposes of the law enforcement agency. I mean, if it turns out, as you say, that knowing whether somebody is male body as opposed to female body as opposed to something else, then the law enforcement agency can, on their own, decide, okay, this is the way we're going to keep records.
Yeah.
Yes, you can. So you can make a distinction between the subject self-reported X and the officer that filled out the paperwork reported Y. And for internal purposes, we're going to use Y, not X. Because we think it's more relevant to our purposes, right? I mean, that seems like, I mean, I'm sure even that would be controversial because we live in a society where everything is controversial.
Yeah.
But so long as you're allowed to self-report, and then whatever agency, I mean, you would think it's the same with a doctor, right? If you self-report, if you go to a doctor's office and you're male-bodied and you self-report as a woman, you really think that the doctor is going to treat you as a woman? I don't think so. I mean, he's a bad doctor. That guy would be a bad doctor, right?
Yes.
So, right. So what is the doctor going to do? The doctor is going to write down on his form, okay, self-report X, but body Y. Therefore, since I'm talking about...
But you have an enlarged prostate, right?
Right, exactly. So since my business my profession is about bodies and not about sociological or behavioral attitudes, then I'm going to proceed on the basis of the body. Now, you go to a psychologist, that's a different issue.
Entirely, yeah, of course.
Right.
Yeah. Let me ask last question, and then I'll let you go. The way you described the sexes, you said the sort of two peaks and then a sort of a bleeding. Right. So an example I've sort of given, and when I've discussed this with people, is I've said, look, the statement, dogs are quadrupeds, is true, despite the fact that there are three-legged dogs, right? So I guess what I want to ask
some of those three-legged dogs are the result not just of accident, having lost a life,
as a genetic,
but the result of either genetics or development. Yeah. Mm-hmm.
So in the absence of natural kinds, how should we understand statements like dogs are quadrupeds or statements like human beings come in two sexes, male and female, which I would say is true in the same way as dogs are quadrupeds, true despite there being exception. How should we understand those statements without recourse to natural kinds?
So biologists tend to use the word biotype. So the biological type of a dog is a quadruped, even though there are exceptions. The biological type of insects is six legs, even though there are exceptions, and so on and so forth. The biological type of a vertebrate is that you do have a vertebral column, and even though there are exceptions, and so on and so forth. Right. So a biotype, it will be the same as in what is called a normal. But normal, of course, the problem with using that word
is meant descriptively.
Correct. Exactly. It's meant descriptively. I mean, the so-called bell curve, it's also called a normal curve. Not because it's prescriptive. It doesn't tell you that unless you fall in the middle of the curve, there's something wrong with you. It just tells you that, statistically speaking, 2 standard deviations of the population are around that mean. That's it. So I wouldn't cancel using the word normal because, of course, it has all sorts of prescriptive connotations. Yeah. People are going to freak out.
You just have to qualify what you mean when you say it. Right. I guess what I'm asking you is, can one really cash out the idea of a normal member of a class without conceiving of the class as a natural kind?
Yeah, I think so, because
So what is it normal relative to if it's not relative to a natural kind?
Let me give an example.
Yeah, please.
So these are all statistical descriptors, right? So if we were in ancient Rome, a normal man would be about a little more than 5 feet tall, because that was the situation in ancient Rome, right? Not because of genetic changes, not like the genes have changed that much between then and now in the last 2,000 years.
So it was nutritional?
Nutrition. Yeah, it was nutritional, right?
Yeah.
So a normal male in ancient Rome would be about 5 feet tall, and then there would be a distribution around that knee. But now, if we're talking about a normal male in North America in the 21st century, no, if you're 5 feet, you're definitely below the norm, statistically speaking. Right, so we can say that we can understand that these norms change over time and change in a continuous fashion due to a number of factors. Because when we say nutrition, it's a little bit misleading because it sounds like it's one factor, but nutrition is a large number of different factors. Right, it depends on vitamins, proteins, the amount of calories you get, when you get them, and so on and so forth. So it's actually not one factor; it's a multifactorial situation. So I don't see anything problematic in saying, look. Right now, in this particular population, the statistical norm is X, descriptively. But in a similar population in another part of the world, it may be different, and it's an empirical question. Even today, there are populations where the average male height is significantly lower, and occasionally significantly higher than the North American population.
And you really think that you can apply that to normal and with respect to male and female, with respect to sexes? Because in the case of height of Romans, there's an environmental and thus a heavily social and cultural component, right, having to do with agricultural technology and practices,
sure.
But that wouldn't seem to be the case with respect to whether you produce large or small gametes, right? I mean, that would seem to me to not be a matter that's affected by social considerations at all. So how do you cash out the statistical norm in that case without some appeal to a natural class? Is I guess what I'm asking.
Yeah. No, that's right. Well, again, now we go back to the beginning. So what do we mean by natural class? I mean, even those so-called natural classes are the result of evolutionary processes, right? So they are, in fact, accidental in a sense. They are the result of certain processes that could have gone easily in a different way. And sure enough, we do know of a number of biological species where there's, the two sexes are reversed, for instance, like in birds, or
one individual has both. I mean,
there are hermaphrodites. There are fish that
reproduction.
There are fish that change sex over their lifetime. So there's all sorts of stuff. So what we see in human beings right now is the result of a particular historical sequence of events. And therefore, you can say, look, for these particular species at this particular point in time, it's true that there is a bimodal distribution. That's what technical term is. It's a bimodal distribution of sexes. There's one peak over here, one peak over there. Those are the two modes.
Yeah.
And then there is a variation in between. And descriptively, that's fine. It doesn't have, however, any kind of prescriptive implication. It doesn't say that if you're in the middle, you should really move to one side or the other. It's like, no, if you're in the middle, you're in the middle. So long as there's nothing that bothers you in terms of physical health, because one of the problems is that, of course, the chromosomal anomalies, and I use the term anomaly, again, not in the
descriptively,
but descriptively, as in statistically rare, right? Some of those situations don't just alter the sexual organs, they alter a bunch of other things, and they can result in health issues. So actually, some of these people do have health issues that need to be treated. But again, that's an empirical question. It's like, what kind of health issues do we have? How do we deal with them? It has really nothing to do, as far as I'm concerned, with sort of rights and access and that sort of stuff. Now, when you were saying, what about people who want to walk into the bathrooms and et cetera, fine. That's, as a society, we need to come up with some kind of
That's a social, cultural, ethical question.
Exactly.
Exactly. That's not going to be solved by calling things something else or not.
We either agree that, fine, there's no need to do gendered restrooms. I mean, now I've been walking even recently into a number of places. I was in a conference in Toronto where there are no distinctions between ladies and men. It wasn't a problem. There were stalls for men or self-described men, whatever it is, that are closed, but they're in the same room, general room. Fine. And that's okay.
Yeah, I guess look, this gets into a whole different territory. It has to do with what one reasonably fears. I will say that, and you've raised a daughter too. I think that I did like the idea that some of the intimate spaces she was going in were going to be sex segregated. And I kind of I thought I was sufficiently right to fear male predation, not to mention her sensibilities, because as you know, adolescents are very body conscious.
I have another issue. When my daughter goes to the bathroom, she just takes too long. So I'd like to have a second bathroom for that reason.
Fair enough. Massimo, thank you so much. This was really interesting and went in all sorts of directions that I wouldn't have predicted, which is always a good thing. And so just before I let you go, do you have anything coming up that you want to mention so that we can keep an eye out? Anything new coming out?
The thing that is coming out is the one that we're doing together with Sky Cleary. Is this book on how to live what is it called again? How to live a good life.
How to live a good life.
Yeah. So it's a collection of, I think, 15 different essays by different people who not only are familiar with a particular philosophy of life or religion, from Buddhism to Stoicism, from Epicureanism to Judaism and so on, but actually are living those kind of religions or philosophies of life. And so it's a kind of a exploration of different ways of living your life philosophically or religiously. And it's going to come out early next year, and I'm sure we can do some interesting video dialogues.
Absolutely. And anything going on in the Stoic world you want to tell people about?
In the Stoic world, there's a lot of stuff going on. As far as I am concerned, I am now being contracted by the Great Courses Company to do 24 lectures on Stoicism, and I'm working on them right now. And they seem to think that this
on
is
video?
a large market.
On video? Is it
on video? That's right. Yeah, they're going to be on video. We're going to be taping them during the summer of next year, and it's going to come out early 2021. It's really exciting because I never done.
How is it going to be distributed? Like on Netflix or like on? How is it?
They have their own distribution channels. They still sell DVDs, and they also have an app, of course, where you can watch videos, etc. But yes, they are in partnership with both Audible and Netflix.
Wow, that's really exciting. That's going to be really interesting. You must be excited about that.
It's a challenge, I tell you, because each lecture is based on a script of about 4,000 words. That means that to do 24 of them, it's 96,000 words. That's a fairly large size textbook. And so it's challenging. And of course, you have to be sort of engaging with the public. I will be presenting the lectures on video, on camera. And it's going to be a lot of fun.
Are you going to be presenting to a live audience or doing it in studio?
No, it's in a studio. They have a really nice, sophisticated sort of television studio where if I want to talk about, let's say, Zeno of Citium in the Agora, they can make the Agora appear behind me. That sort of stuff.
I recorded a video course for Missouri State years ago, and I did it in studio, and then was able to add all sorts of stuff in post-production, which made it nice and graphical and sort of stuff.
Right.
That sounds terrific. Well, Massimo, thank you so much. We look forward to these upcoming projects, and I look forward to talking with you again soon.
Thank you. It was a pleasure as usual.
All right. Take care, my friend.
Bye.
Bye-bye.